Hi everyone, today in Integrated Math 2, we're going to go over Chapter 6, Lesson 5. Here are the objectives. Make sure you write them down in your notes. So, isosceles triangle theorems. Isosceles triangle theorems, if two sides of a triangle are congruent, in this case we have them here, then the opposite angles of those sides are also congruent. So, we said AC is congruent with BC. We know that. Because of that, we can also say that angle 1 is congruent with angle 2. Then we have the converse of the isosceles triangle theorem. Whenever we hear converse of a theorem, it's just the flip version of that. So what they're saying is if we have angle 1 and angle 2 which are congruent to each other, then we know that we have sides opposite them that are congruent. So side DE is congruent with side FE. And there we go. Equilateral triangle. A triangle is equilateral if and only if it is equiangular. So what they're saying is if we know that angle A and angle B and angle C are all congruent to each other, then we know that the sides are also congruent to each other. So side AC would be congruent with side CB, and it would also be congruent with side BA. Then each angle of an equilateral triangle measures 60 degrees. Well, think about that logic as every triangle must add up to 180 degrees. The only way that we are going to get our angles to be the same degree for every single one of them and also equal 180 degrees if each of our angles are 60 degrees when we're talking about equilateral triangles. 60 plus 60 plus 60 equals 180. And that's why each of these angles must be 60 degrees. Alright, example 5. We want to find the measure. So first of all here we see that this side is congruent with this side. So, and we also are given that angle A is equal to 44 degrees. So, and what they want us to do is to find the measure of angle B. So this one is our question. We can have it as x. So if we have two sides that are congruent in a triangle, we know we are dealing with isosceles triangles. Well, an isosceles triangle says that with our theorems, they're saying that if two sides are congruent, then we know that the angles directly across from them are also congruent. Because of that, we can say that the measure of angle A we know is equal to 44 degrees. We can also say the measure of angle B, we still don't know quite yet. We're going to say it's x. The measure of angle C, well, that is definitely 44 degrees because these are the same. And let's recall when we're talking about the interior angle sum theorem, which means any triangle needs to add up to 180 degrees. So we can put this into an equation. The measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. A is 44 degrees. Measure of angle B, oops, yeah, we'll leave it as angle B so far. Plus the measure of angle C is 44, which is equal to 180. 44 plus 44 is 88 degrees. The measure of angle B is equal to 180. I'm going to subtract 88 to both sides. When you do that, you get the measure of angle B, which is equal to 92 degrees. So that x is now 92 degrees. So now we found the measure of angle B, which is 92 degrees. Then we have part B. They want us to find the measure of side AB. Well, We do know we have an isosceles triangle. We know that this side is congruent to this side, which means that we know that AB is equal to 12. And there we go.